Hi everyone, welcome back to the channel. So today in this video we are going to discuss the representation of game tree in AI. I will share with you some simple steps with the help of which you will be able to know how online games are developed. So now let's just start the session. So students, a game tree is nothing but it is a data structure that is used in AI to represent all possible moves in a game. Let's take an example of tic-tac-toe. We have chess game, we have Sam CD, right? So all these are games totally based on AI game tree. So creating and representing a game tree in AI involves a systematically organizing the game states. We have multiple states, we have multiple levels in every game, right? So in AI we need to systematically organize the states and possible moves into a hierarchical structure. So now I will share with you some steps that will help you get a clear idea about it. So the first step is define game rules and representation of states. So at this particular step, we understand the rules of the game. For example, how players move, how win conditions work, all these rules can be defined in this particular state. Identify the starting state and how the game processes. Let's take an example. Let's assume we are playing tic-tac-toe online, right? So we all know in tic-tac-toe, it is a 3 by, we have a 3 by 3 grid where we use cross or O, right? So this is the basic rule or representation of state. At the initial level we all know ये जो ग्रिड है 3 by 3 का ये बिल्कुल एम्प्टी होता है और फर्स्ट स्टेट में हम क्या करते हैं किसी भी एक एलिमेंट को यहाँ पर प्लेस करते हैं कहीं पर भी प्लेस करते हैं. So a player can win by aligning three symbols horizontally, vertically or diagonally, right? So this is the game rule that we use in tic-tac-toe. That is the first step of representing the game tree. Another is identify the initial state, that is the root node. Alright, so here we are going to initialize the root node. So creating the root node representing the initial game state and associate it with the metadata like current player. For example, I have placed this element here. So this is what? This is the root node. This is the initial state of my game. Alright. Next we have generate all possible moves. That is the edges for the current state. Let's say I have placed element here. Second player will place their element here. So this is called the edge. The first element is called the root node. Then another move can be your edge. Alright. So this is how we generate child nodes here. Alternate player can develop child nodes. They can switch from when we switch from this user to this user. Okay, that is called the switch from one place to another place. Now we can also create child nodes for resulting states. We have so many child nodes. Let's take an example. I am placing this element here. So this is another child node. I am placing this element here. This is another child node, right? So we have different levels and different child nodes here. Another is recursively expand the tree until terminal states are reached. सो जब तक एक टर्मिनल स्टेट नहीं आ जाता, जब तक एक एंड पॉइंट नहीं आ जाता, हम क्या करते हैं गेम को खेलते रहते हैं, उसको एक्सपेंड करते जाते हैं, नंबर ऑफ नोड्स जो है वो बढ़ते जाते हैं. असाइन वैल्यूज टू टर्मिनेट नोड्स, टर्मिनल नोड्स. सो एट द एंड we can have three states or we can have three terminal nodes like win, lose or draw. That is also called win is called positive value, lose is called negative value, and draw is called neutral value, that is 0. All clear? So all these are the steps. The last step is use the tree for AI decision making with appropriate algorithms. Other than this, we have some other components that is also very important for your exams. All right. So at first, we need to define the components of the game. So the game tree consists of some components. The first component is node, specifically your root node. It represents the game state. Okay, it is used to represent the game state. This is very important statement. Another component is the edge. It represents the moves connecting the states. These are the nodes, and edges helps them to connect with each other. Represent the moves connecting the states. Another is the levels. So alternate between players. जब एक प्लेयर खेल रहा है, जब हम दूसरी चीज पर शिफ्ट हो रहे हैं, दूसरे एलिमेंट पर शिफ्ट हो रहे हैं इस तरीके से, दैट इज द लेवल. In the second step, we need to choose a data structure. So tree data structure, we are using game tree here, right? So we use tree data structure here. The game tree is often represented as a hierarchical structure where the root node is the initial game state. Its child node represent a state resulting from a move. These are the leaf nodes. They represent terminal states, that is win, lose and draw. So there are three states with the help of which we represent the data structure. Next is traversing the game tree. So once the game tree is built, here we have created a game tree. It can be traversed to 2 points. The first can be to evaluate using algorithms like min-max. Another is to optimize exploration with alpha-beta pruning. All clear? Next is example visualization. So students, for example, if we are playing or if we are making a game tic-tac-toe, at initial level, the root node is the empty board, 3 by 3 grid empty board, right? At first level, all possible moves by player X. I have 9 spaces here. Okay, I can place X here, I can place this element here, I can place it anywhere at the initial level. And in the second level, all responses by player 2 for each of player X move. यही होता है ना इस गेम में. ऐसा ग्रिड है, जो फर्स्ट लेवल है, जो फर्स्ट प्लेयर है वो कहीं पर भी प्लेस करेगा, और सेकंड प्लेयर का मूव जो है वो पूरी तरह से फर्स्ट प्लेयर के फर्स्ट लेवल के ऊपर ही निर्भर करेगा कि उसने वो मार्क कहाँ पर किया है, एलिमेंट कहाँ पर प्लेस किया है. सो दिस इज द एग्जांपल विजुअलाइजेशन. So I hope students everything is clear to you. If you have any doubt you can comment below. So thank you so much and all the very best.